G'day. Today we're looking at integrating the ax plus b to the power of n, or basically looking at integrating the chain rule. So when it comes to integrating the chain rule, we have the same kind of setting out as we do when we integrate a normal function. We raise the n power to n plus 1 and divide by n plus 1. However, in addition to the chain rule, what we do here is we bring our coefficient of our x value out to the front. So we write this here as, we raise it to the power of n plus 1, divided by that new n plus 1, and then multiply it out by the coefficient of ax plus. We then do the same thing. So when we look at exponential, treat it like as a chain rule again. We don't have a power to it, but we do have our coefficient of x. We bring that out as a fraction, so 1 over a times the original function. And when it comes to cosine and sine, we do the same thing as we do when it comes to the exponential. We bring the a value out, 1 over a times by the integral of the function that we're working with. In this case, cos becomes sine, and then we write the original f of x behind it. And then when it comes to sine, remember, it's the opposite. So it's negative 1 over a cos ax plus b. And don't forget, because we're working with indefinite integrals, we have to put that plus c for it's to the constant of integration. Let's get into some examples. We've got 3 examples up here. We want to talk about how we can actually do these type of questions and see how they work in the sense of these calculations. So let's look at the first one. Before we do anything, we need to make sure we get this into its form where we don't have a fraction. So now we're ready to start integrating this one here. We raise it by 1, divide it by 1, bring this out. So this here becomes negative 1 over 5. Don't forget that has to come out. 4 minus 5x to the power of negative 3 all over negative 3 plus c. We now want to tidy this up a little bit, so we're going to multiply this out. So this equals negative, or positive 15, because we've got negative times a negative, 4 minus 5x to negative 3 plus c. Now, because we started off in this sense here, we need to make sure we try and get it back in the way that we started. So therefore, we can rewrite this here as 1 over 15, 4 minus 5x to the power of 3 plus c. And this here is the integral of this calculated up here. Alright, let's have a look at the second one. Now, I'm going to do 2 different ways. The first one I'm going to do in terms of just multiplying out. The second way we're going to do is we're going to bring this constant out. And we'll talk about that when we get to that next example. So let's integrate this. So our first thing here is 3 times negative half, because we bring this out. And why do we make it negative? Because sine becomes negative cosine. 2x. Now, we need to integrate this. This here is the same as doing negative times negative 1 over 1, because we do it as a fraction, e to the negative x. This here then becomes a positive. So we get 3 times negative 1/2 cos 2x plus e to the negative x plus c. Let's tidy it up. So therefore our final answer here becomes negative 3/2 cos 2x plus e to negative x plus c. And this here is the integral of this function. So remember, when we're looking at these types of integration, we're thinking about, well, what is the coefficient of our x value? We bring that out the front. If we're working with trigonometry, what is the integral of sine? In this case, it's negative cos, so we must make that sign out here negative. Alternatively, you can bring it out and make it negative in front of 3. It doesn't really matter in this case. And then with the exponential, this here is the same kind of idea. We've got something in front of x, we bring that out, that over 1, so this here was 1 over 2, this here becomes 1 over 1, but it's negative, and negative times negative gives you the positive, and we get that final answer that we're looking for. Okay. Let's look at the third and last one. Before we do any of these works here, the first thing we do is we want to get rid of this square root. So this here will become 5 minus x to the half dx. Now in the last example here, I didn't bring the 4 out. I placed it still within the integral part, but it wasn't actually being integrated, if you saw. I didn't integrate that function. So we could bring this 4 out and rewrite this here as the 4 integral 5 minus x to the power half dx, because we know that this rule here is if we have the integral of let's rewrite that again. If we have an integral of some constant times in a function, this constant's not actually being integrated. I can pull that out, integrate the function, and then multiply that value back in. So this here can be rewritten as k fx dx, and I would still get that same answer. So that's what I'm doing in this instance right here. In the previous example, I didn't pull it out. I didn't integrate the 3, I didn't pull it out, but I multiplied it when I integrated the half in terms of the sine to x. So that's on the outside, I'm not worrying about integrating. However, I need to make sure I hold its place. So in this case here, the 4 will stay, and then I'm going to integrate everything that's inside. So, let's integrate this. We get negative 1 because of this, so negative 1 over 1 is going to give me 1. 5 minus x to the power of 3 2/2 over 3/2. Whoop. And then we'll whack on our constant of integration. Let's tidy this up a little bit. So we'll have 4. Let's bring this up so we get negative 2/3. Remember, when we're dividing by a reciprocal, we bring this value up. 5 minus x to 3/3 plus c. Now, I've got to this point here, I can now multiply my 4 back in. So therefore, this equals negative 8 over 3, 5 minus x to the 3/3 plus c. And that is my final solution. So for the previous example here, we didn't bring the 3 out. We used that as in terms of integrating within that purpose, but it didn't actually get integrated. However, if we've got a constant, we can bring that constant out and re-multiply it back in later. All right, see you in the next one.